Welcome to the e-learning platform series by Science Park. Today we are going to cover part 4 of force and pressure. In the previous part we have learnt about atmospheric pressure. So let's see what are the topics we are going to cover today. We are going to see a demonstration experiment from which we are going to understand the concept of buoyancy or buoyant force. Next we are going to see or learn about buoyant force. Then we are going to learn about Archimedes' principle. What was his principle? And we are going to see an experiment to verify the same. And in the last, we are going to see an application of Archimedes' principle in which we are going to perform an experiment. So let's begin with the demonstration experiment. Hello. So in this demonstration, I am using a tub full of water and an empty bottle with lid. So what will happen if I keep this empty bottle on the water? Guess what will happen? It's quite easy. I think it will float. Yes, as you can see, the bottle is now floating on the water. I have filled this bottle with water and I have also put on the lid. Now what will happen if I put this bottle in the water? Any guesses? Well, let's see that. Oh, it has surely gone down. So has it sunk? No, it is just floating beneath the surface of water. So I have a question. Why hasn't it sunk? What is keeping the bottle floating just beneath the surface of the water? So then, what do you understand by buoyant force? It is actually a force. Now let's see it. Now in this picture, you see a container filled with water. And there is an object which is floating on the top of the water. Now the object is stationary. That means there are some forces acting on the object and which are balanced. Now let's see what are the forces that are acting on the object. First, the force of gravitation, which is acting towards the center of the earth. And to balance that gravitational force, there is one more force which is exerted by the liquid or the fluid, in this case water, and that is called as buoyant force. Yes, the direction of buoyant force is always upwards against the gravity, and it balances the gravitational force and lets the object float on water. Now we know that there are some materials which float on water. There are some which sinks to the bottom, and there are some material which floats inside the surface of the water. Yes. Now here we have those three materials. Now let's talk about the forces acting on these three materials one by one. So as we have seen earlier, there are two types of forces. One is the gravitational force, another is the buoyant force. Now let's take the first object which is floating on the surface of the water. In this case, the buoyant force is more than the gravitational force. That's the reason it is floating on the surface of the water. Now the second one, the object which is floating just inside the surface of the water. Now this is very interesting case, because in this case the force of gravitation is equal to the force, the buoyancy or the buoyant force. Yes, that is why it is floating inside the surface of the water. In this case, the forces are balanced. And in the third case, the material which is sinking down, the gravitational force is more than the buoyant force. Yes. Now the first and the third case in which the material is floating and has sunk down, these two cases are the examples of unbalanced forces. Right. Now tell me, students, can we measure this buoyant force? Is there any way of measuring this buoyant force? Yes, there is. But then how to measure it? Is it as simple as measuring the weight? Maybe. So there was a Greek inventor and mathematician named Archimedes who came up with a principle in which we can measure the buoyant force. Now, what was his principle? The statement of his principle is, when an object is partially or fully immersed in a fluid, a force of buoyancy acts on it in the upward direction, as we saw. Now, this force is equal to the weight of the fluid displaced by the object. Now, what do you understand by displaced by the object? When you take a container full of liquid and when you place an object in that, some water fills down. It comes out of the container. And the weight of that water which comes out of the container is the buoyant force. Now, enough said. Now we will see an experiment on verification of the same. So in this experiment, we are going to verify the Archimedes principle. For that, we will need a small balance, a container, a glass container, and a piece of stone. So first, we will measure the weight of this stone. So it is 41 grams. We will note it down. Now we will measure the weight of this container. It is 136 grams. We have noted the weight. Now comes the interesting part. Now we have filled this glass container with water up to the brim. We have kept that glass container into this metal container. And now I am going to put this stone inside this glass. Let's do that. So what happened? The stone sank in the water and some of the water got displaced and it fell in the metallic container. Now we are going to measure the weight of that water, container and water, and it is 175 grams. We will note it down. Now we have noted all the weights. Weight of the stone is 41 grams. Weight of the container is 136 grams. Weight of container and water is 175 grams. Now we will calculate the weight of water which is displaced, which is weight of container and water minus weight of container. So 175 minus 136. So this will give me 39 grams. So what Archimedes told is the weight of this stone must be equal to the weight of the water displaced. And we have approximately got it right. Weight of the stone is 41 grams and weight of the water displaced is 39 grams. So we are going to see an application of Archimedes principle. Now friends, this is a very interesting application. Before that, I'll ask you a question. Do you know how submarines work? Yes. Whenever they want, they float on water. Whenever they want, they go inside the water. How is that possible? In the similar way, we are going to perform this experiment now. This experiment is called as Cartesian Diver. Yes. For that, you are going to need a bottle full of water, 2 coins, 2 drawing pins, a piece of straw, scissor, and a matchbox or lighter. So first we have to seal one end of this straw. We are going to do this with the help of a matchstick. So we'll place 2 coins over this straw like this, and then we are going to light the matchstick and seal the end of the straw. And we are going to press it with the coins. So the end is sealed. So next we are going to cut the straw at around 1/3 of the length, this much. So we have 1/3 the length of the straw. Now the end which is open, we are going to fix 2 drawing pins so that it will have some weight at the bottom. You can take help of any adult at your home to do so, because you need to be very careful while inserting the drawing pins. So in this way you have to fix the drawing pins. Now we will take a glass full of water and just insert it like this, just to see that it is floating or not. And you can see the straw is now floating. Now we will take the bottle, open its lid and put this piece of straw with the drawing pins at the bottom like this. And we will fix the lid. Now you can see the straw is just floating. Now the next step is we are going to press this bottle and see that the straw goes down. When we release it, it slowly comes up to its original position. So friends, in a similar way, the submarine works. Yes, and this is a very interesting application of Archimedes' principle. Now what exactly happens when I press the bottle? Okay, as you know, there is a bit of air inside it, right? So air pushes the water below. So when I press the bottle, the air pressure is increased, and due to that it pushes the water. Due to this, some of the water goes inside the straw, increasing the gravitational force or the weight, and that's why the straw sinks in the bottle. We will see it once again. See, it has gone down, and when I release it, it slowly comes up. Thank you. Very interesting experiments. There are quite a few applications of Archimedes' principle than what we have seen. So let's summarize whatever we have learned till now. So we began with an experiment, a demonstration experiment on buoyant force. Then we actually saw what is the meaning of the buoyant force, the force which acts upwards. Then we saw the principle laid down by Archimedes, and the verification experiment of Archimedes' principle. And in the end, we saw an experiment that was the application of Archimedes' principle. Now, as in the previous videos, here we have some questions related to Archimedes' principle and buoyancy. So you can pause the video here and note down the questions, and you can write the answers, submit to us by email, or you can mention it in the comments below. Thank you.